We'll move to our next group of speakers for highlights from OnFarm's first year of work. So we're joined first of all by Don King from the Soil Resource Group. And Don, I will turn things over to you and let you share your slides for this part of the morning.
All right. Thank you, Bronwyn. I guess some have missed a really good introductory talk by Angie that introduced the OnFarm project. So I'm just going to run through a couple of points about the project. For those that didn't hear, it's a 4-year initiative by OMAFRA, and it's administered and delivered by Soil and Crop, and it focuses on soil health and water quality, obviously. It's CAP funded, and it continues the work established under GLASI and researches the priorities identified by Ontario's soil health and conservation strategy. So there are 33 cooperator farm sites involved in the applied research and monitoring aspects of the project. Spread across the province, there are the 8 edge of field sites, which have been introduced by Angie, but they're nestled in the southwest along the shores of Lake Huron and within the drainage basin of the western basin of Lake Erie. So those conservation authorities that are managing those sites are Essex Region, Lower Thames Valley, Upper Thames, the Assello Bayfield, and Maitland Valley. So there are 2 sites in each of the Assello Bayfield, Lower Thames, and Upper Thames to get to that number 8. Also, there's BMP trial sites in groups of 5 in the 5 regions distributed across Southern Ontario. So to provide a sense of the scope of this undertaking, this outlines the data collection activities that the conservation authorities and the Soil Resource Group project partners are involved in. Under the water quality pillar, OnFarm allows for the continuation of the water quality and quantity monitoring and the modeling that was established in the priority sub-watershed studies. And part of that includes the 8 edge of field water monitoring sites where there are cooperators that are implementing BMPs that the CAs will be evaluating to determine their effectiveness in reducing nutrient loads in both surface runoff and subsurface tile flow. There will also be soil health assessments done at those sites annually. So across the priority subwatersheds, there'll be crop management surveys that'll be carried out and used for profitability mapping and running water quality models that will be evaluating BMPs and their effectiveness. So Mary Valise will be expanding a little bit on the CA activities in a few minutes. Under the soil health pillar, the Soil Resource Group is partnering with Soil and Crop to address the OnFarm project goal of relating soil health risk assessment to the predominant soil, landforms, and the management types across Southern Ontario. So the approach establishes a network of side-by-side field trials to investigate the effectiveness of BMPs in addressing those inherent risks and challenges to soil health and productivity. In addition to the research objectives, the practical question of the cost of a BMP and what may be its effectiveness is also being studied. So it was about a year ago at the OnFarm launch, we were in our early days of selecting the network of representative BMP trial sites. So how the BMP trial sites were chosen was based on a great deal of collaboration and several criteria. We began with a list of close to 100 names that were recommended by the soil team of OMAFRA. And after some detailed discussions with them and input from the field crop team and researchers at the University of Guelph, the criteria was narrowed and 40 excellent candidates were interviewed. There was a rating scheme of more than 50 aspects that was developed and considered the potential for a site, the experience of a farmer, and their capability to test the BMPs. They were all used to select that final list of 25. I want to acknowledge 3 people that spearheaded the assessment and the selection of the sites that joined the SRG project team, and they're shown in the picture, along with one of our Eastern cooperators. Adam Hayes on the left is a recently retired OMAFRA soil specialist. Scott Banks is a crop specialist retired from OMAFRA, working with our Eastern cooperators. And Ted Taylor, leaning on his tool of the trade, provides the pedology expertise as a recently retired BMP specialist. For the cooperators willing to participate, they were interested to have detailed assessments done, obviously on their own farms, but were also very willing to share their knowledge and provide access for demonstration of these different BMPs. So the selected BMP trial sites are spread out across Southern Ontario and they're distributed in 5 regions, meant to represent the predominant soil and landform types in each of those regions. All these sites, though, do capture a range of operations with a combination of different conditions and field crop management and history. Soils across the regions were ranked and grouped into 4 texture classes so that candidate sites were chosen that would closely represent the distribution within each of those regions. As you can see, for example, in Western, the predominance of the medium textured and fine loamy soils represented by the sites there, and in Central, where there's more upland and rolling landscapes, there's a greater concentration of sites with a coarse loamy soil texture. Predominant livestock sectors are represented across the sites. We've got beef, dairy, hog, and poultry operations. As you can see, there's some weighting in Western where there's a greater concentration of livestock.
Don, if I can interrupt you for a second. This is Bronwyn. There's a flashing box in the middle of your screen. I think maybe it's something you need to move. Do you see that on your screen?
I do see it. I'm not sure what I'm doing to get rid of that.
I'm not sure. I've never actually seen something like that before. It says move away from your screen. So I don't know if you can grab it and move it or.
Trying, it just advances my slides, unfortunately.
Well, we might have to just live with it. Sorry to interrupt. I just thought if you could.
Yeah, no, I realize that is annoying. So I'll try that again.
We also have your slides. We could share it. And
do you want to do that?
Andrew, do you want to pull up Don's slides? And that's an odd thing. I've not seen that message before. If you could stop sharing your screen, Andrew could pull up your.
Got it. Maybe I'll continue on. In terms of what we found with distribution of sites, we wanted to obviously represent the soils and livestock sectors. And then farmers were asked to consider, I guess we're up to slide 8. We were asked to consider 3 different groups of BMPs to focus on. Perfect. So those that were being considered within the on-farm are cover crops, organic amendments, and reduced tillage. All the cooperators have common field crop rotation, so primarily the corn, soy, and wheat. And after some discussion with individuals, talking about the soil health challenges and the related goals, there was a 3-year plan formulated to implement the range of BMPs that cooperators were interested in. So there were single species, there were combinations of cover crops that up to as much as a 14-way mix, those having varying application and termination methods. Organic amendment treatments included different manure types from the major livestock sectors, as well as from different off-farm sources. So things like municipal biosolids, anaerobic digestates, pellets, green bin waste were some that were being used. Tillage was less of an emphasis, but included vertical tillage, strip till, and no-till. Okay, next slide. So with that as a backdrop and some early spring reconnaissance, the field sites were selected and finalized. And what followed was a bit of a blur, but this monthly photo log at one of our sites illustrates the field activities that were done through the season. So once a field was planted, side-by-side treatment strips in the field were established along with benchmark sample locations. In each of the strips and at 3 contrasting soil and landscape positions. So there's replicated soil health sampling in the month of June at the benchmarks carried out at the peak microbial activity. Agronomic monitoring of the benchmarks was carried on through the season, culminating with hand harvests, in this case in July. After a site was combined, there was a baseline pedology assessment done at each of the benchmarks. BMP implementation at this site, for example, and for all sites with a cereal crop, had cover crop treatment seeded down afterward that in most cases had an organic amendment treatment applied adjacent, as well as a combination or a suite of the two BMPs in another treatment strip. And there's always a check or a control strip without a BMP. So performance of the cover crop BMP was monitored across the treatments as well, including biomass accumulations. And as you can see in this example, the dairy farmer removed the oilage later in the fall to use for feed for an additional economic benefit. Next. Just want to touch on the soil health measurements themselves. And so the package of indicators chosen to best represent soil health currently being investigated by the research community were used in the baseline sampling this year. So they include chemical, physical parameters, but also biological measures that are sensitive to changes in management. And Lindsay's going to talk a little bit about that later on. In addition, a number of field measurements were completed that can be related to the measurements found in the lab. So important among those was a detailed soil pedology investigation. It conducted each of the benchmarks to identify soil health risks within the profile. So here in the picture, Ted's pointing out some of the soil structure and problems. And this provides a greater understanding of that soil health interpretation that would be needed at each of our sites. Okay, next. So with the little time I have, I guess I wanted to touch on a sample of the data analysis so far. We're still getting results coming in from the lab. We're continuing with our stats analysis, but we're in the end developing a baseline of soil health under various field conditions. Next. So this figure is meant to provide a bit of an appreciation for the amount of data collected in year one. The graph shows two soil health indicators, the soil organic matter and soil active carbon, that are considered related to each other, although it may not be so obvious in this mess, but it provides a sense of the variability that exists across the predominant soils and landscapes found in the province. So in fact, all data points couldn't be fit on this graph, as there was an Eastern Ontario site with a lower landscape position with greater than 30% organic matter, which is an organic soil by definition, but it's not uncommon to see this in pockets right across the province. But in analyzing the data set a little deeper, and you start to pull out the numbers by the site and factor, relationships start to reveal themselves. Next. So again, in taking the raw data for a single site, some of the inherent differences start to separate out, in this case, based on landscape position. So quickly looking at the lower end of the orange circles, which represent the upper landscape position, you see lower organic matter levels and lower end of the organic carbon distribution. Mid-slope position, you see them in the blue triangle, showing up further up that linear relationship, and then the higher end of organic matter and active carbon, you see the lower landscape position showing up. So these differences are important to recognize in attempting to measure change at a site over time. I'll also just add that there's a reference site sampled from an adjacent bush or an undisturbed area. Shown in the graph is a light blue diamond in the top of those samples. It's not to be used for comparison for field levels, but it rather provides more information and knowledge of a soil's potential. So the data set we have is obviously very large, it's diverse in conditions, and it provides an opportunity for research on many different aspects. Next. With the amount of information gathered, there's certainly an opportunity for exchange. And under the engagement pillar within ONFARM, Soil and Crop was able to organize meet and greets at 4 cooperator sites this fall, following all COVID protocols, of course, but Invited attendees included OMAFRA, Ag Canada, the Cooperators, the Conservation Authorities, Soil and Crop, the working group members and the stakeholders, as well as the farm media. The feedback from the follow-up surveys indicates that all the respondents said they'd attend a similar event in the future. And just as importantly, the cooperators indicated that they'd implement a new or revise their practices on their own farm after attending. So very valuable. And I guess as much as we all have enjoyed the opportunity to attend more meetings virtually, it doesn't quite match the face-to-face information exchange and being able to see things in the field for yourself. So we do certainly hope to continue with more of these as possible. Last slide. So looking back at the first field season, the project's established 33 sites with a group of tremendous farm cooperators. There's a range of site management, cooperator experience, and soil and crop conditions that can be investigated and evaluated into representing regional challenges to soil health. With the sampling of a baseline data set at all the sites, it represents a great starting point in measuring soil health indicators and their influence from a large number of different management treatments. At the 8 edge of field sites, what we have is 16 different field treatment options. And being monitored for their management effects. At the BMP trial sites, the 25 represent 99 different strips of field treatments that we can learn from. So this year in year one, cooperators successfully seeded a cover crop at 24 of our 25 sites, either following cereal or interseeding, both corn and soybeans, or post-harvest. In addition to the livestock operations, there were 9 cash crop sites with biosolid organic amendment applications from different sources as well. So the study established protocols for monitoring soil and agronomic variables across those treatments. And lastly, I wanted to mention that certainly the achievements this year could not have happened if it were not for the level of the engagement by our cooperators working with us. And it really indicates the commitment and the interest they have in ensuring the soil health project's success. So a big thank you to them. Okay, I'll turn it over to Mary now.
Wonderful. Thank you, Don. That's a great summary of the first year of the ONFARM program. I'm sure there'll be questions as we go through the morning, but in the interest of time, we'll just turn things over to Mari Velis. She is the Healthy Watersheds Manager with the Sauble Bayfield Conservation Authority. And I think she's going to be sharing her screen. So Andrew, if you want to stop sharing Don's slides, we'll do that. And I'll turn things over to Mari.
Okay, can everybody hear me and see the screen okay? I'll get started here, but first I just really want to acknowledge the great collaboration that this on-farm opportunity provides. The 5 participating conservation authorities, the Essex region, the Lower Thames, the Maitland Valley, and the Upper Thames River. Of course, we really also acknowledge the hard work by the Ontario Soil and Crop Improvement Association and the funding from OMAFRA and Ag Canada. So I just want to talk a little bit about watersheds, which is perhaps a little different scale than most are used to thinking about, and why we monitor watersheds. So surely there are different approaches that we could use to evaluate best management practices. And when I thought to present some of the results from this last year, I recognized that some of what we can talk about are things that are the real need for longer term information. So certainly patience came to mind, that we have to kind of wait for some of these results to make get longer term ideas of what's happening. The other P that I want to mention is perspective. And we can surely look at different approaches to evaluation, whether that's agronomic or economic. But when we look to ecological, there's a lot of different factors there as well. There's the field, the edge of field, the lake, and the watersheds. And why we look at watersheds is really if we want to understand the loads and what influence the best management practices have on those loads, we do need to measure water. And to do that, we have to look at watersheds. And finally, the people part of this is so important. And yes, this last year was more challenging for us to work with our partners in coming together, but we did have unique opportunities, smaller field group visits, and more virtual visits as well to keep building our collective knowledge about best management practices. So I'm going to start with the edge of field studies that all the watersheds have some edge of field studies where water quality leaving the field is observed. The Lower Thames, for example, with key support from cooperating landloaders, have established a long-term comparison of water quality in 2 adjacent Brookston clay fields in Merlin Township. Although both farmers follow a corn, soya, wheat rotation, and there are slightly different fertilizer regimes. The main difference in the one system, the Merlin A system here, is that it utilizes tillage to manage crop residue prior to planting corn. And the Merlin B system involves drill seeding soybeans and corn directly into cover crops at planting, and a practice that is often referred to as planting green, sorry. Please note that the preliminary data presented here, and I'm not sure if folks can actually see this because my box is over top of it, but suggest that there has been some concentration reductions in the field that is that has the cover crops and less tillage, and we see less total suspended sediment and total phosphorus concentration. The soluble reactive concentrations are very much different, and these analyses were done by the University of Waterloo. As far as what that means from a loading perspective, the Lower Thames tells me with only 18 months of data, it will take some time to begin to see some of the changes that we might expect to see with respect to the volume. And this is really like a great example of what can be done when we have time: edge of field water runoff monitoring and cooperation. But how do we measure what's happening in other fields? So this is the Gully Creek watershed that goes directly into Lake Huron, where the Subtle Bay field has been working. And one field that we are looking at here is essentially mini watersheds in this field. And within this field, after the wheat has been finished in a corn, soy, wheat rotation, this farmer first applies dairy manure and then plants a cover crop with clover and oats, and which he typically harvests as feed. And this fall, he left one of the mini watersheds covered and didn't harvest it for our benefit. The problem with having this in-field experiment is we don't have good control over what would happen for good sampling. So this winter we are having a typical winter, which the last few years we have not had. So we're not having that freeze thaw and the opportunity to collect those different samples. So, and that's going to be an interesting finding, but does that mean that we won't have any data? It depends, because we could also have a thaw that is quite extreme. So we just have to kind of wait and see. And I guess what I bring this up is because if we don't have as much data, does that mean we won't have information? And the answer to that is no. I guess one other point I want to make about this is this little field here is this corresponding little yellow box here. And why we can use the information that we collect, even if we don't generate a lot of runoff this year, is because we will use ecosystem models or watershed models such as the SWOT. And what that does is by looking at the soil conditions, the topography of the landscape, the weather conditions, and observing the flow in various points in this watershed, we can begin to simulate flow in an ecosystem model. So this is what this kind of thing looks like, this graph on the left, is that what we can do is we can have the measured flow here in the blue and the modeled flow following in the red. And even if it's just the frequency of flow, and if we have a big runoff or small runoffs, this helps to us understand our watershed flow regime. And what we can do is turn on or off different agricultural best practices that have been happening within the field. So for instance, we could say that we had cover crops in those fields and see what the difference in the flow and the loads would be. What we found when we begin to look at this data in this way is, this is some of the results from earlier. We can see reductions in phosphorus at the field edge with respect to the planting of cover crops in some of these fields over the 2 years. However, in the watershed outlet, and this might be hard to see because it's behind this box, the concentrations the reductions are lower, less than 1%. And this, depending on where we're looking at the impacts of these BMPs, they'll have different impacts. And this really points to a couple of things. One is that it probably will take higher numbers of fields with best management practices other than 3 in this watershed of potentially 70 fields to make that broader ecosystem difference. And the other thing it might point to is some issues around the volume of water. And again, this is important when we're looking at this scale. Water, where it flows and when it flows, is important to begin to document. In order to really make those models work well, we need very good regional data. And so this is something the Essex region has been really working on to streamline for us this past year. So I mentioned that we needed soil data, we need weather data, we need slope data of the landscape, but we also need very good land management data for all the fields in the watershed. And when I speak to that, this spreadsheet here that I've depicted here is 140 lines. And so for each of the fields, this is the kind of data that needs to be collected. And I know that Essex region this past year has really spent a considerable amount of time trying to make the ability for us to accumulate this data a little bit quicker through some different GIS techniques. So I've talked a little bit about perspective, so field edge and watershed scale and sub-watershed scale. But now and those are just the ecological perspectives, and I recognize that there's also socioeconomic perspectives as well with some of these factors when we look at best management practice. The next P I want to talk about is patience and the real need for looking at some of these issues in the longer term. So the Upper Thames here shows some of their findings over the last 4 or 5 years. And essentially what you can see here, or actually this is just 3 winters, is during the growing season, we have low creek flow, and during the winter, the non-growing season, we have higher flow and higher loads. And that's a pattern that continues. What will be interesting is in 2021, when we add on to this graph, what the loads and the creek flows are when we have a more traditional year. And the other point that's interesting when you think about that is it also points to another reason why we need to use the ecosystem models. And that is, if we were to put in quite a few BMPs, which we have done in the past, and then have weather that overrides any of the impact of the best management practices, people would be wondering, well, what is the impact of these best management practices out at water quality? And it really helps to have that model so that we can take out influences of climate, so that we can begin to appreciate the impacts that best management practices are having. This other graph that's at the bottom here is something the Maitland Valley has worked on over the last 8 seasons, and really just it shows here the amount of runoff that we might anticipate in the late summer versus in the winter time, or late fall, sorry, and the number of events. So less than 1 in the late summer, and then 5 events around 60 millimeters in the late fall. And this has real implications for certain land use, like land management activities, such as the application of manure. So again, on the patience piece, I just wanted to highlight the time that it does take to set up some of these watershed studies, to work with the landowners to kind of get the experimental design. This is some work by the Upper Thames here, where they have tried to show over the winter of 2020 what would happen on in a watershed basis with more field edge cover, more fields covered with either cover crops or hay and pasture versus less. So getting all that set up, collecting and compiling all those data that I talked about for the model, but also just the actual water quality data, and then communicating these methods and some of these preliminary results as well, because not everybody learns in the same way. And we know that we all want to understand what the impacts of some of these best practices are, not only on our own fields, but what difference they could make from a water quality perspective. And so this is where really working with the cooperating landowners and all the different interested stakeholders really is important. And we also recognize that there are different approaches for people to learn. And so some people are going to learn with scientific peer-reviewed literature, and other people are going to learn in a more hands-on way. So it really is highly important for our project that we have been able to engage with the interested landowners in our watersheds. It has really made some of these longer term studies quite a bit more easy to accomplish. We also recognize that some of this work is fairly complicated and complex, and we realize that we couldn't possibly study this everywhere, but we do need to study it somewhere. And this is just a map highlighting some of these watershed areas. And at less than 1%, at 0.002% of the watershed, trying to understand water flow, at least that helps us begin to understand some of these more complicated dynamics with respect to water. And we're really happy this year to be involved with the soil resource group that's going to really help all of us collectively understand more about soil health and what those linkages are between soil health and the ability to hold water, and looking at that from the watershed perspective. So we're looking forward to that. We hope everybody can have patience for recognizing that this water is such a dynamic feature, really influenced by weather and all kinds of practices, and trying to piece out the parts about the best management practices does take a little bit of time. So thanks everybody for their patience on that. And then of course, we just really want to acknowledge all the hard work and the commitment from the specific landowners in our watersheds. The first map I showed in Merlin Township there, I know that some of the tiles were dug up and a water sampling port was put in. So there's been really a tremendous amount of enthusiasm from our local landowners, because I think we're all keen to see how the BMPs work at our field, but also how are they contributing to the water quality improvements that we all look forward to seeing. So that's all I have for today, and I just really want to thank everybody for their time this morning, and looking forward to the lessons learned by all of us collectively over the next couple of years.
Wonderful. Thank you, Mari. That was great. I love the 3P kind of way of looking at things with the perspective, patience, and people as being really key parts of how the on-farm research can be successful. So thank you very much for that presentation. We are getting some questions and comments in the chat, and I see Angie has answered one, which is great. And I think there's a question there that maybe some more science people might want to answer about instruments available to monitor open drain flow and that. So if anybody has answers to those questions, please feel free to go ahead and put them in the chat just so we can keep our morning moving along. There's another question there about the challenges with removing the climate effect on BMP, because as we all know, Mother Nature can have some major weather events at any time of the season. So if Don or Don King and Mari and Angie, maybe a couple other scientists, if you have answers to these questions, that'd be great to put those in the chat, and we can summarize them later in our report that will go out to everybody. With that, I will turn things over to Lindsay Van Coffen. Lindsay is a graduate student at the University of Guelph and also a Climate Smart Soils intern with Ontario Soil and Crop Improvement Association. And Lindsay, I believe you'll be sharing your screen, and I'll turn things over to you. Thanks again, Mari, for your presentation.
Thanks, Bronwyn. Hi, everyone. As Bronwyn mentioned, my name's Lindsay. I'm a master's student at the University of Guelph. I'm studying soil microbiology there. And for the last about 6 months, I've been working on a project for the ONFARM program. So now I'll just share that project itself and some of the results that came out of it. So the reason this project came out in the first place is due to a program I'm a part of called Create Climate Smart Soils. This is spearheaded by Dr. Claudia Wagner-Riddle at the University of Guelph, who I think I saw in the forum today. But the goal of this program is to train students like myself in sustainable soil practices and bring these skills with them to the agricultural sector. So on top of our graduate programs, we have to partake in additional items aimed at professional development, one of which is an internship, which I have decided to do with Ontario Soil and Crop and the ONFARM program. So upon starting this internship, we were trying to find a way to link my background in soil microbiology to the ONFARM pillars, specifically the engagement one. And after talking to a lot of people from this program, we landed on what we're calling soil microbial health modules, the goal of which is to create a resource to educate cooperators through knowledge translation and transfer on the importance of their soil microbes and how they play a role in their soil health. So we got feedback from the cooperators through an online survey about their knowledge on the subject and what they're most interested in learning to eventually develop those modules. So I just want to take a second here to highlight why educating producers on soil microbiology is an important opportunity in the first place. First, it's the fact that soil microorganisms, they play a huge role in soil health, and giving producers the opportunity to learn about this can help them make more informed decisions on management practices and hopefully highlight the importance of using BMPs like those used in the ONFARM program. Another reason is that this is still a relatively new subject in research. There's still a lot of questions that are unanswered, and farmers can help put the pressure on researchers to get those answers out. And there's also an emerging opportunity for soil microbes to be used as soil health indicators, which is just opening up the doors for producers to have more interest in and access to these types of tests. All right. So as I mentioned, we handed out a survey to all the cooperators participating in ONFARM, and we asked them just some general questions about soil microbiology and how it relates to soil health. So I just want to share some of the answers that we found most interesting here. So one of the questions asked was whether or not they've taken part in any soil tests that target soil microbes to measure soil health. And among the 20 or so that answered this question, only 3 of them had done so. So we asked, what's stopping the other 84% of them? And we found that just a lot of them don't know what options are out there, or they don't know how to interpret the results. And to a lesser extent, some didn't think the results were useful or didn't think that there was enough research to back up the tests. But what I thought was interesting was no one actually stated that the costs of these tests were a barrier for them. So then we asked those who've gotten the test done what they thought of it, and we got some important answers here as well. So the positive side was that these tests allow you to compare the results over time, but the negative was that there's really no normal or no benchmark to be able to compare your results to, and that there's also too many outside factors that are playing a role in the results to really understand what's going on. So these answers I thought were super interesting. I really think this highlights the importance of being transparent with farmers about the research and the capabilities of these tests. So I just want to show you two more questions from the survey. The first one is we asked, just what they're most interested in learning about when it comes to soil microbiology, just any specific topic. And the answers were super widespread. So I grouped them into several categories here, which are general soil microbiology, the roles that microorganisms play in soil structure, organic matter, and nutrient cycling, as well as the effects of non-plant inputs on soil microbial communities. And lastly was soil biological testing. So these answers sort of guided how I went about creating the modules, trying to help give them an understanding of all of these topics of interest. And so lastly, we asked if they had any really specific questions they had on this topic. And a lot of the answers we got here were about, what can they do in their management practices to better the performance of their soil microbes, which again was a key focus of the modules that I've created. So just to give you some of the answers here, we had questions about tillage, about fueling, how to fuel the microbes, about what they can do to enhance nutrient cycling, and then two great questions about if following BMPs and the tools that farmers already have is good enough to improve soil's microbial health. So from all of that, the final result is 4 modules in the format of small informational videos, each covering a different topic. The main topics are Introduction to Soil Microbiology, which encompasses a general overview, a summary of the soil processes that microbes are responsible for, and a brief overview of what can change or improve these communities. The second module is on cropping systems and how they affect the soil microbial community. And there's also a touch here on tillage. And then we have fertilizers, covering the effects of inorganic and organic fertilizers on soil communities, as well as biofertilizers and what they aim to improve. And the last 2 modules that I just mentioned, they're very research focused. So we go over a few studies that highlight the effects of management practices on soil microbes. And lastly, the fourth module, is on soil biological testing and just sharing what metrics are out there and the limitations to some of these tests as well. So these modules will be up on the ONFARM Applied Research website, hopefully fingers crossed by the end of this week, where cooperators and anyone really who's interested can be able to use them as a tool to better understand this topic. And so I just want to finish by thanking everyone who helped me with this project, especially Angie for guiding me along the past 6 months, and for all the cooperators who took the time to give their feedback in the survey.